Hi everybody, welcome to this week's tutorial. In this tutorial I want to go over some of the topics we have discussed, particularly nested loops, and do some cool examples with you. So as usual, please make sure you start processing and program along with me. First of all, I wanted to go through this code that I talked about in the last lecture. So this processing code, when you run it, it generates this shape. It's a square shape filled with small circles. As I mentioned, if you're a processing programmer, the main output that you generate, basically the only output, is what happens in this window. When we do print statements, that's not really the output of the program per se. That's print statements are usually done to do debugging in processing. So if you took my advice, hopefully you took my advice last time and did a memory diagram for this code. If so, you should know if when this shape is drawn, if it is drawn in the vertical direction. So are the columns drawn first or are the rows drawn first? Which do you think happens first? First of all, I should say that this window, this output window, is not updated while the loops are running. When you exit the loops, this is updated. While you are still in the loops, this isn't updated, but it's being drawn. As soon as you exit the loops, then it is drawn. So very much like the draw function. At the very end of it, you draw something. So with processing, there's always this invisible line. When you're done your task, then it updates the window. So let's go through this and see if we can, if you know what exactly is happening. I don't want to spend a ton of time on this, but I want to make sure that we understand it. So basically, in the inner loop, you have ellipse I and j. So in the inner loop, you have j being updated. You have j being updated. So every time I is updated once, j is updated 15 times, basically from 100 to 400, and it is being incremented by 20. So j is incremented 15 times. So that means our circle is drawn in the, so that means you're drawing the columns first, right? Because j is representative of y here, the y coordinate of the center of the circle. So the way this actually works, and make sure you do a good job of understanding how this works, and maybe draw the diagram for yourself. But you enter it, so you have the outer 4, in which you have I, and then you have the inner 4, in which you have j. So when I is 100, you start with j being 100, and then you draw this once at 100 and 100. Then j becomes 120, so you draw it in lower. Sorry, this should all be the same size, so I'll try to. And then j becomes, and then of course j becomes 140. You draw it, then becomes 160. So all the way you draw this to the very end. And then when you're done, so when j is in fact 400, you're done. This thing is completely destroyed. You go back up, I will become 120. That means you move over here, and then the inner loop, and then you enter the inner loop again. So you get like a scope created for the inner loop, like that. Then you get another j at 100, because that's where you are. So this thing is drawn, and then this becomes 120, 140, and so on and so forth. So that's how your 2D structure works. Now, if I went ahead and I actually changed this and I said ji, then it would be drawn in a way that you would have the rows drawn first, and then you would have basically the rows drawn, which is kind of transparent to what we're trying to we're trying to build. So hopefully you're clear on that topic. If you're not, please make sure to come and ask me and ask the TAs. It's very important that you understand how these loops work. Again, it's not really a programming concept per se, it's more mathematical, understanding how these loops function. So let's do a couple of cool things with this. First of all, I did a couple of things where I made it to look like a triangle rather than a perfect square. We can try to color this, right? So if I set up here, fill, let's say 255, 0 and 0, like that. So that's colored red, right, with the RGB. So if I draw this, then it's going to be filled with red zeros. Let's make it interesting. What if I wanted to not make this entire thing as red, but what if I wanted the diagonal to be red? So I don't want all the circles to be red, but I want the diagonal going from up here to down here red. How would I do that? So it's a pattern, right? It's basically a pattern that I am looking for. So what I'm saying is I want this shape. Let's say I'm just drawing it 3 by 3, but I basically want the diagonal here to be red. So how do you do that, right? It's a pattern. So if this is I, right? If I say this is I, so this is like 0, 1, and 2, and I have J being 0, 1, and 2, do you detect the pattern here? So do you see what pattern it is that we're doing with regards to Y and J, if I is here and J is here? Well, if you have I0 and J0, you have red. If you have I1 and J1, you have red. And if you have I1 and J2, you have red. So that means if I is equal to J, you should color it red. Simple as that. So that's what I would program. So instead of just saying fill, I would put a condition here. I make a decision. So here I have a decision structure inside a repetition structure, and you see we're going to be able to do a lot more interesting programs. So if I equals J, then you fill. If it doesn't equal J, then you don't do anything. So notice my spacing now. Like if I go Control T, it sort of indents everything for me. So I don't know. I guess it's a little more clear. So let's run this. Still all red. So why that is? It's because once you set fill once, it's always gonna be set, right? So it's not an if problem. They have to also have an else. So you say if this is the case, if I equals J, you fill, else. So since there's only one statement, I don't really need braces per se. So I could say fill, and I would just say fill the rest whites, which is just fill 255. And let's run this. And that's what we get. We get red across the diagonal. So here's a challenge for you. Write a program that does, and I might actually just give something like this to you in for your studio project, but maybe you can start working on this. It's a challenge. So that I made this diagonal. The other diagonal is a little bit more tricky. So come up with a pattern. It's all about patterns, you see. Once you know the pattern, you just quickly program it. So make it so that the other diagonal is also red. So you have an X inside. So that's my challenge to you. The other program that I wanted to do with you quickly was, I took a screenshot of it. I wanted to do this. So how we can go ahead and we can put the color of these circles alternating between green and red, so which is pretty straightforward. It's a pretty cool shape. So how can we draw this? Well, again, any 2D shape, it's nested loops. So you have to come up with the pattern. What pattern do you see here? The pattern really that you see here is on or off, right? So you're either red or green, red, green, and so forth, and basically that's how it works. So the way you would do that is one way, and there's always multiple ways to do these problems. One way to do that is to set up what is called a flag or a Boolean operator. So you basically say a Boolean variable. So you basically say Boolean, I'll just call it red is true. And I'm going to go here and say, okay, well, so this is my flag basically. When this is true, color it red. So I'm going to say if red, or I can say if red equals true, they both work. If red fill it with red, and turn red off, so you don't want it to be red anymore. So then set red and set it to false, and then simply else. So let me bring this down a little bit. Else fill green, and when you fill green, then you need to turn red back on, so it toggles, right? So if we run this, you see the shape is created. So lots of fun things you can do with this. A lot of different things. So I'll basically leave it up to your creativity to come up with different things. But there are a lot of different shapes you could do. And it's just you got to figure out the actual pattern. I'm going to do one more quick question, and that is, so let's erase this. That is, let's create a really simple multiplication table down here, right? So just in the console this time. So multiplication table, you've seen them. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you have, well, you've seen on multiplication table, right? Let's do one quickly. So if I made 4 int I equals 1, I less than 10, or it could be less than or equal to 9, I plus plus, and then 4 int j, the same thing, j less than 10, and then j plus plus, and then here print I times j, and we want to have a space, and I'm just going to do a print ln like that. So this is hopefully going to, let's run, and we get our little multiplication table. This would have saved me a lot of time if I knew how to do this in grade 2. So the spacing is a little off just because they're 1-digit numbers and then they become 2-digit, but this is essentially what it is. So it's pretty cool, right? You can do a lot of interesting things with it, and hopefully you guys have a lot of fun with this lab, because I think the labs are going to get a lot more fun because you know a lot of constructs now. Thank you. Good luck.